Now, in this section, we're going to be talking about higher order derivatives and the shape of functions. So in this video, I'm going to start with introducing to you what higher order derivatives are and their functions. So here, higher order derivatives, actually by its name, previously what we were doing was the first order derivative. That means we were deriving the original function, which is y equals to fx, for only once. So it's first order. So now if you're doing this again, then it's a second order derivative, right? So if you're deriving a derivative of a derivative function, then this derivative twice is called a second order derivative or second derivative on the slide. Okay, so usually it's noted as f double prime of x. One prime means derive it once, and here double prime means you're deriving it twice. Or it is a more complicated way of putting it, but seeing this d over d, and here there are several squares, you know it's a second order derivative. So the first order derivative tells us the instantaneous rate of change, or namely the slope of the tangent line, right? And the second order derivative now tells us how the rate of change is changing, how the first order derivative is changing, right? So basically, derivative just tells you how the previous function, how the original function that you are deriving on is changing. So now the second order derivative is basically tell you how the first order derivative changes instantaneously, right? So basically how the slope of tangent line changes. So let's look at the real world example. So if let's go back to the previous, say, travel example. So if we say the original function is distance, so the original function is distance. Distance is y equals to a function of time, right? So now the first order derivative actually tells you the change in distance for a changing time, right? So that's speed. If it is, say, the average change rate of distance per time, then that's the average speed. We use delta y over there, the t in this case. But if it is an instantaneous change rate, right, of distance per time, then we're going to be looking at where the indicator is on your odometer. At this moment, how the distance is going to change per this time, right? So that is what first order derivative is. The second order derivative now tells you how the first order derivative changes. So basically how your speed changes. So how do we raise up your speed? Well, you push the throttle a little harder, right? In that way, you are putting up the speed, but how do we decrease the speed? Well, you hit on the brake, right? Or you loosen the throttle. So in both ways, we see we're doing things to change the speed. And here, deceleration means you're making the speed lower. You're making the previous first order derivative to decrease, right? If you're accelerating, push the throttle harder, right? Then that means the first order derivative, which is speed, is increasing. So basically here, I'm giving you an example telling you the function, the use of higher order derivatives. So basically, it is to tell you how the first order is changing. And here, specifically in this real life example, we have a sense of what the first order is, which is speed. And here, second order derivatives basically tell you how do you change your speed, right? Basically, or if I put it graphically, then it is basically how does the indicator on your odometer spin, right? If it is accelerating, the speed is going up, then it's a clockwise spinning. If it is decelerating, then it is an anti-clockwise spinning. Okay, so those are the basic concept of derivative, higher order derivatives.